May 26, 8 o'clock. So Jerry asked me to buy these for his cameras and Wi-Fi up in the mountain of Solano. With this size and having this specs of 30,000 milliamp hour, if you take away the thousands milli, this would be 30 amp hour. Imagine 30 amp hour with this size. And for one pack, it's 734 peso. I'll link up not link up, but take a picture of the Lazada. So, knowing that this is false advertisement, I decided to power up the device, power up this device with this. So I fully charged the battery last night. I took it apart. I don't need to show how to take things apart. You should be able to figure it out, how to take things apart. So I'm going to measure the current draw between this, or measure the current draw of this device. So I'm just gonna take the meter and desolder this part and series the amp meter. So disconnected power to the router and remove this cable which is connected to the jack, and I got my amp ready to be doing this. Okay, I've set up this thing. I have alligator clips and black to that wire, and then the red probe. So we're going to measure the current draw. So now the Wi-Fi is on. The current draw right now is 100 milliamp, and we'll see when it's steady state. How do I know it's steady state? All of the relevant LED there will be on. So P on, label will be on. Okay, it's blinking on, and 2 LAN ports are active. And so the current draw here is 240. It's dancing around since I don't have a proper probe. Anyway, it'll steady state as soon as the 2 blinking whatever is sort of steady also. Then the current draw will also steady. Oh yeah, and the Wi-Fi WLAN is on, and so the current draw now is at 350. So from 350 it goes up. So we can use whatever number there that seems to make sense. For example, it seems to be sitting around 350, more or less around. So we'll just use 350 as the baseline for calculation. So I'm going to reconnect the wire so that I don't keep holding it for several hours. So I'm just gonna redo it. The reason why we did this is to get a steady state current draw. So I'm gonna turn it off. So it is off. So I reconnected the wire, and we're going to measure the voltage, initial voltage, before we plug it into the router. The voltage is 12.28. So we're going to plug it into the router. So the router is plugged. So the voltage is at 12.23. So as soon as the WLAN is on, it'll draw more current because it's transmitting and receiving. The voltage would drop. So now it's 12.2. So it was so as soon as the WLAN is transmitting, drawing more power. Now it's 12.21. This will take several hours, probably around 7 hours with that kind of draw. I think this is, I mean, this is so silly. I don't know why they fake the specs. Look at this CE. I can't remember what C, FCC, recycling. I mean, this is crazy. CE, nonsense. Actually, if it's CE, the circuit board would also indicate what was the rating. I can't remember. I'm too old now, but this would have the necessary marking to reflect CE. So I don't see the marking. So this is all fake. That's the way it is. So 30,000. In reality, this is probably less than 3,000 milliamp hour. So this will take time. Since it's drawing 350, we can do some quick calculation. So quick calculation, 30,000, I divide that by, let's see, 10. I mean, they're multiplying this by 10 times. Yeah, crazy, silly. So it's actually 3,000. So Wi-Fi current draw is 350. Duration of this, okay, 3,000 milliamp hour divided by the current draw 350 milliamp. So in theory, it should be 8 hours 30 minutes. So we'll see how long is this true. Is it 8 hours 30 minutes? So 8 hours later probably. So this is the setup. Let's go at it. So the battery died. I set the timer to 6 hours 30 minutes, and there was a remaining time of 10 minutes. So basically, it stayed alive for 6 hours 20 minutes. Basically, yeah, that's how long it will be. And the voltage was 9.8 before it died. So that's how it is. It's good enough for 6 hours. Over time, you discharge this thing. The time of 6 hours will become 5, 4, whatever. Then it's time to replace it. So so the test is completed. I'm putting back the battery to charge. So it lasted basically 6.33 hours. So doing some math, the actual duration, like I said, I set a timer to 6.5 or 6 hours 30 minutes, and the leftover was 10 minutes, and I subtract that from the timer, 6 hours 30 minutes. So calculating the actual capacity, it's 6.33 times 350 milliamp gives you 2215 milliamp hour. I did a ratio of 6.33 over 8.5 because this calculation, it's not real. And I was curious if I were to do another evaluation, I would expect the 8.5 would be basically 15% less. Is that a 15%? Whatever. Um, So basically, it's 0.74, 74% of the stated capacity will come out. So it's 6 cells. So 2, 4, 6, and this is how it's set up. So knowing that the capacity is 2212, and each parallel cell do not add to the current, it just maintains the current. What adds up is the voltage. So because there are two in parallel, basically the capacity for a single cell is 1100 milliamp hour. So this is a 1100 milliamp hour. So that's typical of this product that comes from China. They I don't know, fake, scam, whatever. They make the product look attractive, and if you don't know what you're doing, and you say, "Oh, that's 30,000 milliamp hour in that package. Great. It'll meet my requirement, whatever your requirement is will be." And then when you receive it, you'll be totally disappointed. My Jerry said, "Well, it's for the fun of it." So I had fun, and hopefully you guys have understanding of how to calculate things. I mean, that took a while. 6 hours, 30 minutes, 7 hours, give or take. Quite frankly, this was my second test, and my initial test it gave me 2500 milliamp hour. However, this time I was methodical in my tests. So that's why I set the timer to 6 hours, uh, 30 minutes, because the first test I did was around that. It's actually almost 7 hours. But I did some things wrong. My setup from yesterday was all messed up. So this time I was quite methodical. So this is lessons in life about buying batteries in the Philippines, and the product comes from China. Thanks for watching.